In this video, we're going to start Chapter 1. And Chapter 1 should be mostly, if not all, a review for you. Remember, there is a prerequisite for this course, right? This is college level chemistry, and you don't get to college level chemistry without having chemistry previously. So I do assume that you've all met the prerequisites, which is either Chemistry 130 or its equivalent, or a high school chemistry course. And I do assume that you haven't forgotten everything that you learned in that course also, because I know not everything is fresh, right? You know, in your mind, and you probably have forgotten some of it or you're rusty. We will review it, but I am going to go through it pretty quickly. You actually do have the advantage this semester of the fact that these are videos instead of sitting in a live lecture. So you do have the ability to go back and watch things more than once if you need to, which is great if you're a little rusty, particularly on things that I'm going to go through pretty quickly. The first part of the chapter is on the scientific method, and this is one of those that I'm just going to go through really quickly. I do expect you to know the steps of the scientific method. This is how we acquire new information in science, and it's particularly important, actually, in the world we live in today. There's so much information out there about the coronavirus and just a lot about health and nutrition and things that are just not correct. It's very easy for someone that doesn't have a background in science and has not done due diligence and has not gone through the method to make a YouTube video and put it out there and people watch it and believe it, but it's not backed by facts and experimentation in science. So it's always really important to have, you know, a little bit of what am I trying to say? To have a discerning eye when you're looking at things, right? Is it backed by science? Did it follow the method? Is it reputable? That sort of thing. Or is it just someone's opinion? If it is, well, it might just totally be false. I can't spell, apparently. Sorry, guys. You will learn that I am a horrible speller. Scientific method. It's definitely not one of my strengths, so I apologize. So basically, in general, the steps of the method, our scientific method, is you have a question. So you want to define whatever that question is. You're going to gather information and resources about that question, and then you're going to form a hypothesis. And I'll write this down in a second for you. Our hypothesis is really just an educated guess. It has not been proven yet. It's based on the research that you've done and scientific reasoning, but it's really just an educated guess at this point. Then you perform experiments, collect data to try to test that hypothesis. You analyze that data, interpret that data, and draw conclusions. A lot of times those conclusions may lead to more experimentation. So that whole part of it can just be a big cycle. Experiments, collect data, analyze the data, interpret data, draw conclusions. Often that leads to more experiments. And that just kind of repeats, sometimes for years. Sometimes you need to form a new hypothesis because your experiments showed your first hypothesis to be incorrect, so it became modified in some way. Hopefully at some point then that data can be published, and then it usually kind of sits for a while. There could be another lab in another part of the world that then tests the same hypothesis, and after a while you could, a theory could be developed. And one of the really big things that I do want you to know, something that I will test you on, is the difference between that hypothesis and a theory. Remember that hypothesis is just our educated guess. It has not been proven yet, right? We haven't done research. There hasn't been experiments and more experiments and more experiments on it. It's just our best guess at that time. Our theory is something that has stood up to repeated scrutiny. It's after the experiments again and again and again, right? Then we come up with our theory. A theory is not a law. A theory can still be disproven. A theory can stand for a very long time, and then a new theory comes along that weakens the old theory. So there are things that we used to think that were correct, and based science around it, or based, kind of how we went about our world around it, that have been proven incorrect. So it has stood up to repeated scrutiny. However, it is not a law, right? It can still be disproven. It can also be strengthened. That's a process too. So kind of just real quick again, we define a question. We research it. So gather information. resources. And then we form our theory. Sorry, wow, hypothesis. Form our hypothesis. And again, remember, a hypothesis is essentially an educated guess. It is based on the information that we've gathered, resources, scientific reasoning, but again, at this point, it's just a guess, an educated guess. We perform experiments. I'll try to make that legible for you. Collect data. Analyze the data. Interpret data. And eventually, hopefully, draw some conclusions. And then again, that whole part can just often gets repeated. Sometimes a new hypothesis. And then hopefully eventually we end up with our theory. And our theory is what our hypothesis becomes after it has stood up to repeated scrutiny. Like, generally it's years. You don't just do one experiment and your hypothesis becomes a theory. It's been validated many times. And again, remember, it's not a law, right? It can be disproven. When we start talking about atomic structure, we'll talk about the Bohr theory of the atom, which was the theory that we followed for years. We now follow quantum mechanics. So it can be disproven. Sorry, that says disproven. I've tried twice. We'll give up on the third time. Oh, I can't give up on you guys. Sorry. Can be disproven. Strengthened, etc. So, like I had said before, one of the big things I do want you to know the difference is between a theory and a hypothesis. It's really common to use the word theory when we mean hypothesis. Like if you're just talking casually with someone and they say something and they're like, well, it's just a theory. It doesn't, I don't really know. It's just a theory. It's never just a theory. Right? A theory is something that has been validated many times. There's been years of research spent trying to validate it. What you mean is it's just a hypothesis, right? That educated guess is my hypothesis. A theory has been validated many times. So it's not just a theory, right? It's never just a theory. It's just a hypothesis.